In this video, I'm going to discuss about Aeolian landforms. So these are formed by wind action. So wind is a minor agent of geomorphic agent because of the low density of the air. Because when we compare with the other geomorphic agents like water or glaciers, seawater, so all these factors have all these have a high density when we compare it with wind. Though it is a because of a minor age, though it is a minor agent of geomorphic change, but it forms many landforms. An Aeolian process involves erosion of dry, loose geomaterials and transportation and deposition of these materials. And a region where it occurs more is this process is most active in arid and semi-arid regions, because here the region is dry, so it can easily erode because of the wind action. The geomaterials can be easily eroded and transported very easily. So regions of tropical and temperate environments, hot deserts are most affected by this process. Conditions determine Aeolian processes are arid and semi-arid regions. So arid and semi-arid regions where less rainfall, so the rainfall is less and the water availability is poor, so that here the loosened geomaterials can be easily transported through the wind. And a lack of soil moisture and sparse vegetation. If vegetation is poor, erosion is very active in that region. And large supply of consolidated sediments and rock composition, and very high daily annual range of temperature. Suppose annual range of temperature, suppose in the daytime it's very high, at the night it is very less, so that because of that rocks expand and shrink. So because of the expansion and shrinking of those rocks, and it disintegrates the rocks, mechanical disintegration can easily happen through this, and disintegrates, and because of that the wind can easily transport those disintegrated rocks. And poor rainfall region where the sudden torrential rainfall resulting into stream floods, so that then this stream floods also erode the material which were there, and this also helps in the Aeolian process of our wind, in the process of wind erosion and transportation. And high velocity winds, if velocity speed of the wind is more, the carrying capacity of the geomaterial is going to be high, so this also affects. And the humidity also affects the Aeolian processes of weathering. So deflation, sandblasting or abrasion, attrition, saltation, surface creep, through these processes the weathering takes place. So deflation means blowing away of loose rock materials. So the loose rock materials which are there, they are blown away by deflation process. Sandblasting or abrasion, here erosion of rocks through mechanical friction of rocks. So because of the mechanical friction of the rocks, the weathering process occurs. Whereas in attrition, here is a mechanical tear and wear of particles. So particles occur during the process of transportation. Suppose a large many particles are transported, each material strike against each other, and the size of the material decreases. So that's how the attrition process occurs. Saltation, so saltation here suppose these are bounced. Suppose here material is there and these bounced like this. So again it is bounced like this, bouncing and jumping of the particles. So that's how the saltation process occurs. It's a movement of sand particles through jumping, bouncing, hopping by turbulent airflow. Whereas through suspension also, whereas these are fine through suspension process, only the fine particles are transported, whereas by saltation process the larger particles can be easily transported by bouncing. And surface creep, there's a traction, so here it is bounces and goes, whereas traction, it just rolls like this and moves. So movement of larger particles along the ground surface, so along the ground surface it moves, that's called surface creep. Erosional landforms, long continued erosion forms deflation basins, mushroom rocks, Inselbergs, Demoiselles, Zeugens, Dreikanter, stone lattice, wind bridges and windows. So these are the erosional landforms. The first one is deflation basins. So these are depressions formed in the deserts due to removal of sands through the process of deflation. So because of that deflation, which means it removes the loose material which are there in the desert region, they are blown away by the wind. So because of that, what happens, it forms the basins. So in these basins, water also collects in these basins. These are also called blowouts or desert hollows. Depth determined by the groundwater table, and size varies from small to larger size. So these are deflation basins. So next one is mushroom rocks. So here we can see this is in the shape of the mushroom, so that's why we call it as a mushroom rocks. This is formed because of the abrasive work of the wind. Because of the mechanical erosion, what happens, these kind of undercut mushroom shaped rocks are formed. Upper part is, so the upper part is broad where the lower region is, so base is narrow and more affected, resembling like an umbrella, and this is also called as pedestal rocks or Pilsfelsen rocks. So next one is Inselbergs. So these are isolated hill-like structures. Here the upper region we can see that it is narrow, the base is broad. So these are called Inselbergs. These are residual hills rising above the flat surfaces. These are landforms of relatively resistant rocks in arid regions. So these rocks are more resistant, that's why they are still stable there. And these are also known as Bonhards after the name of the famous geomorphologist. And Demoiselles, here these are, so here we can see Demoiselles. Here these represents the rock pillars having relatively resistant rocks at the top and the soft rocks at the bottom. So here we can see resistant rocks are there on the top. So resistant rocks are on the top and the soft rocks are at the bottom. So these are pillar-like structures. Pillar-like structures are formed because of the erosional process formed due to differential erosion of hard and soft rocks, and the structure will remain intact as long as the cap rocks are maintained and seated on the top. So these are the cap rocks. If the cap rocks remain intact, this structure will remain. If the cap rock is collapsed, and the entire structure will be collapsed. So these are called Demoiselles. Zeugens, so these are formed by the abrasion and the rock masses of tabular form resembling a capped ink pot standing on the softer rock. So this is a tabular structure rock forms. So the alternate thaw and freeze disintegrates the rocks which are blown away later, because suppose the increased temperature during the daytime and the reduced temperature during the night, so because of that alternate thaw and freeze process occurs, so which disintegrates the rocks, and because of the disintegration of the rocks it becomes very smaller, the rock particles become smaller and they are blown away later by the wind process, by the wind movement, and the base is broader than the top. So here we can see the base is broad where the top is narrow, so this is called Zeugen. So this is Erosional. So this is also looks like Zeugen, but is a longitudinal structure. This is a longitudinal structure. It's larger than the Zeugens. It's a streamlined protuberance carved from the bedrock by the action of abrasion and deflation. Steep-sided, deeply undercut regions. Important feature is parallelism. So we can see that here each rocks are parallel to each other and separated by long grooves. It's separated by long grooves, and height varies from 8 meter to 60 meter. Size range from a meter to kilometers, and formed in the regions with alternate beds of hard and soft rocks, also known as coxcomb. So this is also known as called coxcomb. Dreikanter is a ventifact. These are faceted rocks. It has many faces. Faceted rock boulders, cobbles, pebbles formed by long period of wind abrasion. Ventifact can have up to 8 facets, and a rock boulder with 3 abraded facets called Dreikanter. Suppose if it has 3 facets, then it is called Dreikanter. If it has 2 abraded faces, then it is called Zeugen. Stone lattice. So here this is a honeycomb-like structures are formed. The process of weathering, also called honeycomb weathering, and rocks with varying composition and resistance are eroded by powerful wind abrasion and forms fluted and pitted rock surfaces called lattice. So these lattices are formed like it looks like a honeycomb, and hard rocks are less eroded, whereas the weaker sections are more eroded because suppose hard rocks and because of the rock composition is different. It has hard rocks and weaker rocks, and because of the differential erosion, stone lattices are formed, which are also called honeycomb structure. And wind bridges and windows. So powerful wind abrasions causes holes in the stone lattices. So what happens, these holes are gradually widened and reach the opposite side of the rocks. So here we can see that, so reaching this side is abraded, and it is reaching the opposite side and forms a hole like structure here, and this is called windows. A window like structure is formed, so it's called windows, and these are called windows. During abrasion and deflation, arch roof like structures are formed. So arch roof like structures are formed, so these are called wind bridges. So because it is in the shape of the bridge, so it is called, and it is also on the top of that surface, so so this is called a bridge. Whereas windows it forms in the stone structure. Because of one end is eroded, it reaches the other end. Because of that, these windows are formed. Wind transportation, so wind directions are highly variable, because depending upon the pressure variations and temperature variations of particular region, so wind directions will vary. It's a very dynamic process. So transportation differ from other agents. Transports through saltation, suspension and traction. So saltation we know by bouncing the material. There are material suspension which are just the finer particles are suspended in the air itself, and traction just it's creeping along the floor of the surface. So through these processes it transports. Wind transportation depends upon the wind speed. If the wind speed is high, the transportation process also going to be speeded up. Whereas the wind direction, so the wind direction is in the same direction, it can occur. The deposition process can easily happen, erosion process can easily happen in the same direction, but wind direction is very variable. So this also changes the transportation capacity, and the size of the particle is small. Suppose suspended particles can reach a longer region than the process through the traction process, which are larger particles when we compare with the saltation through suspension particles which are transported. And nature of the regions, all is affect the wind transportation. Depositional work of wind. Deposition of wind blown sediments occur due to reduction in the speed of the wind. So suppose it's speeding wind is coming to a region, suddenly decreases, the speed decreases, then there deposition occurs. And suppose if any obstructions like bushes, forests, lakes are there in the path of the wind, then deposition occurs there. Sand depositions occur on both the sides of the obstruction. So if the windward direction and as well as the leeward side, suppose this is the windward direction, this is the leeward side, this is the windward side, but this is the leeward side. Both the side the deposition occurs and forms sand shadows. If sand accumulates between obstacles, these all called. Suppose this is an obstacle, so wind is blowing like this. It is here between the obstacles here. Suppose it's not a continuous obstacles like this. Between the obstacles here it is deposited, then it is called, because suddenly the change in the wind movement, the speed of the wind, here deposition occurs, which are called sand drifts. Depositional landforms are ripple marks, sand dunes and loess. Ripple marks, these are small scale wave-like depositional features of sands formed by saltation impact. Saltation, we know that it's a bouncing of materials from one place to other place, and it can be divided into two types: longitudinal ripples, transverse ripples. It is longitudinal in shape, then it's called longitudinal ripples. If it is in transverse shape, then it is called transverse ripples. Sand dunes, so heaps of sands are called sand dunes. It is formed in the regions where sand is available. So most significantly in the desert region. Even it can occur in the coastal region also. Sand dunes, coastal, wherever sand is available, there it can happen, but most significantly it occurs in the desert region. And height varies from few meters to several hundred meters. Length also varies from meters to kilometers. And the slope angle, windward it will be 5 to 15 degree, and it is gentle, where the leeward slope angle it is 20 to 30 degree, and it is going to be steep. Sand dunes formation begins with accumulation of sands in the form of low sand mounds due to obstruction. So in this low sand mount region, again the deposition occurs, and because of that, what happens, the mound itself becomes obstacle to themselves and cause gradual accumulation of sands in that, so that sand dunes grow in the size. They grow in height and length and form large sand dunes. Formation of sand dunes requires abundance of sand, high velocity winds, and obstacles in the windward direction, and suitable places for accumulation of sand. All this process helps in the formation of sand dunes. Dune complex or chain. Suppose the group of dunes are there in a particular region, then it's called dune complex or chain. It can be formed in coastal region, inland or desert region or riverine regions, wherever the sand is available. So this and the wind action is there. Wind can transport the sand particles and it can deposit and form sand dunes. But the size will be varying depending upon the availability of sand. Migration of sand dunes. So most of the dunes are mobile, so it is not a constant. Dunes won't be it's not a stable feature. It is always a mobile feature. But it's a slow process. This process involves movement of whole sand mound moved to the low angle of windward and then fall into the leeward side. This process is repeated and the grains move forward to cause migration. So in this, know that this is the windward direction, but the leeward direction. The sand particles move like this and then it slip like this. So this move like this and slip like this. So this process is continued like that. The migration of sand dunes occurs. The rate of migration varies from few meters to 40 meters per annum. So it's a very slow process. So it is harmful as it buries large areas like agricultural land, settlements under sand. So it's a very harmful process. Types of dunes: small dunes, which is also called nepka, formed in the lee of the shrub. Crescentic lunate. So these are formed in the small desert depressions, which are also called playas. Wind shadow dunes, formed in the lee of a hill, and longitudinal dunes formed parallel to the wind direction. Transverse dunes formed transverse to the direction of prevailing winds. Birchan dunes, they are transverse dunes transformed into birchans. So birchan dunes are also a transverse dunes and crescenting shape with two horns, and windward side slope is gentle convex and leeward side slope is steep concave, and horns project downward. So depending upon the shape, like we can classify it into many types of dunes. Longitudinal dunes, we can see it's a longitudinal in shape, but this is a transverse dune. So this is a steep side, whereas this side is a gentle. So this will be the leeward side, but this side will be the windward side. This, since it's a steep side, here two horns are there. So this is a transverse dunes. So next one is Loess. So they are thick deposits of unstratified, non-indurated, buff-colored, well-sorted, fine-grained sediments. So this is not a well-developed or feature. It's somewhat a featureless landform. Size of sediments will be 0.05 to 0.02 millimeter. Consists of quartz, clay, carbonate minerals. Deposition occurs at distal places from the source of sediments.